Most of us in Telecom have spent way too much time clicking through portals for routine tasks like setting up customers. Wouldn't it be nice if you could just talk to your systems instead? Well, that's exactly what we'll show you today. In 2026, voice AI isn't just for asking Alexa to play your favorite song, it's about helping real people do real work. Imagine saying, create a new customer and give them 5 Cloud PBX extensions, and it just happens. No typing, no forms. In this demo, I'll show you how we connected PortaBilling to a voice AI agent built with LiveKit and the Model Context Protocol or MCP server so you can onboard customers simply by speaking to the system. We'll leave the links to both tools in the video description. Before we jump into the demo, let me show you the architecture of the voice AI agent. By understanding these components, you can see how everything fits together. Here's what we are working with. First, we have PortaBilling, your telecom platform that manages customers, products, extensions, billing, and everything else. It has a comprehensive API that we are going to tap into. Second, there is the MCP server, short for Model Context Protocol. We covered it in our previous videos, but think of it as a translator. It takes PortaBilling's API specification, that's the technical documentation of all the API endpoints, and automatically exposes them as tools that an AI agent can understand and use. This means the AI agent doesn't need to know the exact API schema. Instead, it just browses the available methods and picks the one that suits the task I need to create a customer, and then invokes it with required data, and the MCP server handles the technical details. Third, the LiveKit server manages real-time voice connections. It's an open-source platform built on WebRTC for video, audio, and data applications. This allows users to join a virtual room and connect an AI voice agent to it. Fourth, the AI agent itself, a Python application built using the LiveKit framework. It uses DeepGram, a cloud voice AI platform, to convert speech to text and text back to speech, OpenAI's models to interpret your requests and generate responses, and the MCP server. When you talk to it, it understands what you're asking for, uses the MCP tools to interact with PortaBilling and responds naturally. And finally, LiveKit Playground, a simple web interface that connects to our voice agent. Think of it as a testing environment where we can talk to the agent and see what happens. Now let's look at how these components work together. For this demonstration, everything except PortaBilling, DeepGram, and the OpenAI platform is running locally on my machine. This is a real functional setup. However, I'm not going to walk through the installation and configuration of each component. That would take an entire video by itself. Instead, you can refer to the official documentation for LiveKit and the MCP server setup using the links in the description below. The focus today is on showing you what's possible and how the pieces work together. Let's take a look at the diagram of how this all connects. As you can see, the flow is straightforward. You connect to the LiveKit room through the Playground user interface in your browser. You connect the AI agent to the same room. When you speak, DeepGram converts your speech to text. OpenAI processes your request and decides what to do. If the AI agent needs data or wants to perform an action, it calls the MCP server. The MCP server translates that into a PortaBilling API call. PortaBilling responds with data or confirms the action. OpenAI generates response, DeepGram converts it to speech, and you hear it in the room. Alright, let's see this in action. Here is my setup. PortaBilling is running in the cloud and its API server is accessible by authorized users. The MCP server is running on my machine. It's already loaded PortaBilling's API spec to expose the tools that can be used by the AI agent and ensures a secure and authenticated connection to PortaBilling API backend. The API specification in OpenAPI format is available on your PortaBilling system too, and you can click the link to download it as shown here. The LiveKit server is running locally. My AI agent is running and connected to both LiveKit and the MCP server. And here is the LiveKit playground in my browser. The interface is simple, just the connect button, chat box, and an audio indicator. When I connect, I'll be talking directly to the AI agent. Now let's see what it can do. Imagine you're onboarding a small business customer who needs a Cloud PBX setup with 5 phone extensions. Normally this would involve multiple steps through the PortaBilling admin interface and the customer's self-care portal. Let's see how the AI agent handles it. Alright, I'm connected. Let's start the conversation.
Hello, how can I assist you with PortaBilling tasks today?
Check if we have customer named Voxtel.
I'll look up the customer list to see if there is a customer named Voxtel. I checked, and there's no customer named Voxtel in the system. Is there anything else you'd like me to check or do?
Yes, let's please create a new customer, Voxtel. Give them $100 of credit limit. Make their billing period monthly. The time zone should be America, New York, and the contact person is John Smith.
I'll create a new customer named Voxtel with a $100 credit limit, monthly billing period, New York time zone, and John Smith as the contact person. The new customer Voxtel has been created with a $100 credit limit, monthly billing period, New York time zone, and John Smith as the contact person. Is there anything else you would like to do?
Yes, let's create 5 extensions for the business.
To create the extensions, could you please provide the extension IDs and any specific names or details you want for these extensions, or should I create them with default names and IDs?
For IDs, let's start with 1001 through 1005.
I'll create 5 extensions for customer Voxtel with the IDs 1001 through 1005. Should I assign default names or any specific names to these extensions? Also, do you want these extensions to be published in the directory or not?
Yes, let's assign random names and let's publish them.
I'll create 5 extensions for customer Voxtel with IDs 1001 to 1005, assign random names, and publish them in the directory. I ran into an issue creating the extensions because each extension needs to be assigned to an existing account or product. Could you please provide either the account IDs or product IDs to which these extensions should be assigned?
Find the product ID for product named business.
I'll look up the product list to find the product ID for the product named business. The product named business has the product ID 2991. Would you like me to assign this product ID to the extensions for creation?
Right, yes, I do.
I'll create 5 extensions for customer Voxtel with IDs 1001 to 1005, assign random names, publish them in the directory, and assign the product ID 2991 to each. The 5 extensions with IDs 1001 to 1005 have been successfully created for customer Voxtel. They are published in the directory and assigned to the product business with product ID 2991. Is there anything else I can help you with?
No, thank you.
See that? The custom was actually created in PortaBilling. The AI agent used the MCP server to complete the task. And here are all 5 extensions, 1001 through 1005, each with the business product assigned. So the AI agent successfully provisioned Cloud PBX services on demand. Now let's break down what actually happened during that conversation, because understanding this will help you see the power of this approach. First, I asked the agent to check if we have any customer records named Voxtel. The AI agent used the MCP server to confirm that no such records exist in PortaBilling. Then I said I needed to set up a new customer, and the AI agent recognized this as a customer creation task. I provided the company's name, billing period, contact name, credit limit, and the time zone, which is the information needed to onboard a new customer properly. Once it had that data, the AI agent called the MCP server with something like add customer with name Voxtel, currency USD, time zone America, New York, monthly billing period, contact person John Smith, and a credit limit of $100. The MCP server looked at its tool definitions, found the appropriate PortaBilling API endpoint, in this case the customer creation method, formatted the request correctly, and sent it to PortaBilling. PortaBilling created the customer and returned the response with the customer ID. The MCP server passed it back to the AI agent, and the AI agent told me the customer was created successfully. When I said create 5 extensions, the AI called the extension creation API 5 times, associated each extension with a customer ID from step 1, assigned the product ID to each extension, handled the sequential numbering 1001 through 1005. When I asked the AI agent to search for a product named business, the AI agent called the MCP tool to search for products. The MCP server queried PortaBilling's product catalog, filtered by name, and returned the product ID. Then the AI agent gave a command to create 5 extensions with that product ID. All of that happened automatically. The AI agent orchestrated multiple API calls through the MCP server, and PortaBilling processed each one. What's remarkable here is that I never had to interact with or even know how to use the API. I didn't need to specify parameters or format JSON. I just spoke in natural language, and the AI handled all the technical complexity. The MCP server takes PortaBilling's open API specification and automatically generates tool definitions, where each tool maps to an API endpoint. The AI agent sees these tools as available actions it can perform. Now, what we just demonstrated, customer onboarding and extension provisioning, is just one use case. But once you have this foundation in place, the possibilities expand dramatically. Let me share some other scenarios that become possible with this architecture. Use case 1, customer self-service. Give customers access to a voice agent they can call to manage their account by natural conversation. For example, check my account balance, do I have any outstanding invoices, upgrade my plan to include more data. The agent identifies the customer by the caller's phone number, retrieves the corresponding account in PortaBilling, and then reads and updates billing data in real time to complete the request. Use case 2, dispute resolution. A customer calls and says, I was charged twice for my subscription this month. The agent can use the caller's phone number to locate the customer account in PortaBilling, pull up their billing history, identify the duplicate charge, explain what happened if it's an error, log a support ticket, for example, to proceed with a refund, update account notes for audit purposes, all without requiring human support agent to log in and investigate. Use case 3, technical troubleshooting. Customer, my phone service isn't working. The agent uses the caller's phone number to locate the customer account in PortaBilling, checks the account status in PortaBilling, identifies the issue, maybe the account balance reached their credit limit, explains the problem, offers to process a payment to restore the service. The key insight here is that anything you can do through PortaBilling's API, the voice agent can potentially do through conversation. You're essentially adding natural language as an interface to access your entire telecom platform. And because everything goes through the API server with role-based permissions, you maintain complete control over what the agent can and cannot do. And the best part? Today, AI agents may be integrated with business telephony to handle queries over phone calls. Imagine having a team of coworkers who never call in sick, don't take vacations, and don't even pause for a coffee break. Before we wrap up, let's address the elephant in the room: security. You might be thinking, this is impressive, but I'm not comfortable giving an AI agent access to my production PortaBilling system. That's a completely valid concern, and here's how you maintain control. Guardrails. When you develop your AI agents, you implement so-called AI guardrails, which are additional checks that ensure AI systems operate safely, ethically, and within defined boundaries by monitoring and filtering both user inputs and AI outputs. Let's look at a few specifics. First up, role-based permissions. The MCP server connects to PortaBilling using API credentials. These credentials have the same role-based permissions as any other PortaBilling user. You decide what the agent can access and what it can do. For example, you might allow it to read customer data, create new extensions, and update service plans, but restrict it from deleting customers, modifying billing rates, accessing payment card details. Next, audit logging. Every action the agent takes goes through PortaBilling API, which means every action is logged. You have a complete audit trail of what was accessed, what was changed, and when. And finally, data privacy. You can configure PortaBilling's API to anonymize sensitive data. The agent can still do its job without seeing full credit card numbers, complete phone numbers, or personal addresses. If you're ready to try this for yourself, we recommend a staged deployment. Start with read-only access in a test environment, then gradually expand permissions as you gain more confidence. Deploy to production only when you're fully comfortable. The bottom line is, you are in control. The AI agent only has access to what you explicitly give it through PortaBilling's permission system. And there you have it. We've gone from concept to live demonstration, showing you a voice AI agent that can manage PortaBilling through natural conversation. We created a customer, found a product, and provisioned 5 extensions, all by simply speaking to the system. No clicking through menus, no complex queries, just natural language. And as we discussed, this is just the beginning. The same architecture enables customer self-service, dispute resolution, technical troubleshooting, and so much more. But here's where you come in. We want to know what use cases you'd like to see built with this technology. Share your ideas, and we might feature them in future videos where we build and demo exactly what you are asking for. If you found this valuable, hit that like button and share this video. Subscribe to the channel so you don't miss our upcoming deep dives into building these solutions. Thanks for watching, and I'll see you in the next video.